Good day everyone. In today's video we are going to attempt to find the height of the stack in terms of radius r. We have three circles of radius r stacked together as we have on the screen right now. That is, we are looking for the distance from this point up to this point, and it is designated as h. The first step we are going to take is to draw a line from this point down here. Good, a straight line. Then the next step for us is to identify the center of each circle. Yes, the center of the first circle, the center for the second circle, and the center of the third circle. Then we're going to join these centers together. The first center joining the second center. Good. Then the second joining the third. Good. Then the third joining the first. Good. Now, from here to here, from this point to this point is a radius. From the center of a circle to any point on the circumference is a radius. Alright. Now, from here to here, this is the center of the circle to this point. It's also a radius. So that makes this place too, from this point to this point, that makes it a radius. Then we have, let's now label this point from here. Follow my green ink. From here, follow my green ink to this place. Let's call it small letter h. So the capital letter H that we are looking for is actually a sum of r, this r, plus h, this h, plus r, this r. So if we're able to get our h, the small letter h, then we can find capital letter H in terms of R. Now we're going to trace out a right angle triangle from the equilateral triangle at the center here. Just follow my, okay, let's label this part. Let's label this as A, let's label this as B, and let's label this as C. Now follow my green ink. I have that, this, and good. So let's redraw it here. We have something like this. It goes down here, and we have this. So this is B. Yes, this is B, sorry, and this is A, and this is C. We have our small letter h to be here, and BC is a radius because B is the center of the circle to the point on the circumference. That's a radius. So BC is a radius. So line AB from B to this circumference, this point on the circumference, is a radius, and from this point on the circumference to A is another radius. So radius plus radius, we have radii, 2 radii. So this will be 2r. So using Pythagoras theorem, we are going to solve for h, making h the subject of the formula. Triangle ABC is a right angled triangle, so here is 90 degrees. So using Pythagoras theorem, it states that the square of the longest side of a right angled triangle called the hypotenuse is equal to the sum of the squares of the other two sides. So here is the hypotenuse, which is 2r. So we square the hypotenuse side. So 2r squared is equals to r squared BC, and AC is what? H. Then h squared. So 2r squared, that's going to give us 4r squared, and that is equals to r squared plus h squared. Subtract r squared from both sides of the equation, so we have 4r squared negative r squared is equal to h squared. So this is 3r squared equals to h squared, and we can rearrange this. H squared equals to 3r squared, and we're going to find the square root of both sides of the equation. So we end up having h is equals to square root of 3r squared. So which is h is equals to square root of 3 multiplied by square root of r squared. So h, this is square root of 3, so square, we cancel square roots, and we have r. So h is actually r square root of 3. We're close to the final answer here, so we have h is equals to r plus r, that is 2r plus small letter h. So capital letter H is equals to 2r plus, what's our small letter h? We've calculated for it. That's r square root of 3. Okay, so capital letter H, we're going to factorize 2r plus r square root of 3. R is a factor for 2r plus r square root of 3. We put it outside. Then we have 2 on the inside of the bracket and square root of 3. So here's our final answer for the height of the stack in terms of r. Thank you so much, guys, for watching.